When writing an equation for a graph, the first thing I'm going to do is look for all the key features that I can find. So I have here a vertical asymptote at x equals 4, and I have a horizontal asymptote that's running right through here. Notice here y is 0 and here y is 1, so that horizontal asymptote has to be halfway in between here where y is 1/2. So that's the line y equals 1/2. So I am going to think about my little parent function f of x equals 1 over x. This graph has asymptotes at the x-axis and the y-axis, and looks like this. So its center point is 0, 0. Notice the center point here is at 4, 1/2. Okay? So one of the things we think about is, how did this graph move to get over 4 and up 1/2? Okay, so we're shifting it over and up. Another thing that we should notice about this is that if I go over to 1, I go up 1. Okay, so this point here is over 1 and up 1, because if I put 1 in for x, I get 1 for y. Notice this point is over 1 and up 1/2, not up 1. Those are going to be some key things that we're going to notice when we look at how to write the equation for this. Now there's two methods for writing this equation, and I'm going to show you method 1 and method 2. I don't care which one you use. So method 1 is thinking there are 3 things that can change in the original equation. I could change the stretch of the graph, which would change this numerator. I could change the left and right shift, which would change the denominator. I could change the up and down shift, which would add or subtract some number to the original function. So what are those numbers? Well, if I'm shifting to the right 4, and this is a vertical asymptote, that tells me my denominator has to have x minus 4 in it. If I'm shifting up 1/2, so I've gone over to the right 4 and up 1/2, that means I had to add 1/2 to the whole function. And this top number is my vertical stretch. Instead of going over 1 and up 1, I went over 1 and up 1/2. So this number has to be 1/2. Now, if that doesn't make total sense to you about the stretch, there's another way I can do this too. I could think of, and this is what the graph looks like, or the equation looks like. I could also think, looking at the first 2 pieces of information, I have f of x equals some number over x minus 4 plus 1/2. I know 2 points, 5, 1, and 3, 0. So let me put 5 in for x and 1 for y. So I have 1 equals a over 5 minus 4 plus 1/2. So that's 1 over a divided by, or 1 equals a divided by 1, which is just a, plus 1/2. 1 equals a plus 1/2, so a has to equal 1/2. So that's a check on this. Also, if I put 3 in for x, put 3 in for x, I would have 1/2 over negative 1, which is negative 1/2. Negative 1/2 plus positive 1/2 equals 0, and that's what I get for this point. So that's method 1. Method 2. Method 2 is maybe a little harder for this problem, but might be easier for some other problems, so I still want you to kind of think through this with me. Method 2 is looking at a function that has an x to the first in the numerator, so x plus or minus something in the numerator. So we'll call this ax plus or minus b over cx plus or minus d. In other words, remember that because this is not an asymptote at 0, that means this is a horizontal asymptote that is other than 0. It has to be an x over an x rather than a constant over an x. So it has to be an x over x, and these coefficients tell me where that asymptote will be. These coefficients would tell me, or these constants would tell me where the y-intercept is. Remember, if I have a 0 in the denominator, that would tell me where my vertical asymptote is, and a 0 in the numerator would tell me where my x-intercept is. So I'm thinking of all those things. So it's going to end up looking something like this in the end. But let's just start one piece at a time. I do know that there has to be an x minus 4 in the denominator because I know that I have a vertical asymptote at 4. I also know there has to be an x minus 3 in the numerator because when I put 3 in for x, I get 0 for y. Remember, 0 over anything in a fraction is 0, as long as the denominator doesn't equal 0. Now, I have to have 1/2, though, for my y-intercept. Right now, this would just be 1 over 1. This would be like 1,000,000 minus 3 over 1,000,000 minus 4, putting in a really big number for x. This would level off to 1. As x gets really big, y would get close to 1. I need it to get close to 1/2. So what I have to do is I have to make this 1 and make this 2. So this turns out being x minus 3 over 2x minus 8. Now let's just double check that with our other point 5,1. If I put 5 in for x, so let's just check this. 5 minus 3 over 2 times 5 minus 8 equals 2 over 10 minus 8. 2 over 2 equals 1. Check. So that works. So my other equation is f of x equals x minus 3 over 2x minus 8. I can also kind of double check my y-intercept should be about -3 over -8, about 3/8. And you can see my y-intercept is just underneath the asymptote. My asymptote is at 1/2 or 4/8, so that looks very reasonable. So that's two different ways to write the equation of the graph. Either way is fine. Now the second equation only has one way to do it, and it really doesn't take as long as you might think. This is a line with a hole in it. We learned that when we have a slanted asymptote, that it has to be an x squared over an x. In other words, there's two factors in the numerator, but just one factor in the denominator. Also, we know that that whatever is in the numerator when we divide it by the denominator, there has to be no remainder, because that's the kind of graph that gives us a line with a hole, instead of a linear asymptote with a big gash in it. So I know that there's going to be two factors in the numerator, and one of is going to be the same as the one in the denominator. Well, I know what the denominator is because there is my undefined value when x is 6. So this has to be x minus 6. So this also has to have an x minus 6 in it. Now, when I cancel these out, when I divide, what's left over is the equation of the line. So this other factor is just the equation of the line. So let's look at the line. We're just thinking of y equals mx plus b. What is m and what is b? Well, if we look at the equation here, it has a y-intercept of 1. And if we go over 1 and up 1, it also has a slope of 1. So this is just x plus 1. Now, we can check this out by putting in another point. So, for example, let's just pick this point here. 1, 2, 3. 1, 2, 3, 4. So this is the point 3, 4. If we put 3 in for x, we should get 4 for y. That should work. So I have 3 minus 6 times 3 plus 1 over 3 minus 6. Well, 3 minus 6 over 3 minus 6, let's put in 3, you get 4. That actually makes perfect sense because 3 plus 1 is 4, so that makes sense. So anyway, this is the equation of this line. So there's a couple of examples. Now when you do your homework, you'll also be working with polynomials. Remember, polynomials do not have any undefined values. They do not have denominators. Polynomials are just a series of factors multiplied together. Sometimes they might be linear factors or quadratic. They might be squared. So think about all the zeros of the polynomials, write factors to go with the zeros, put a different leading coefficient if necessary. So it's a completely different way of thinking than the rational functions.